Hello, physical geology students. This is the last video for your class on July the 20th, 2020. A strange year for all of us because of this quarantine. I know you're going to be depressed that you're not going to see my face anymore, but what you could do is get a prescription for 120 milligrams of Prozac a day. You could drink a lot of gin and tonics. You'll get over it. Anyway, let's talk about deserts again. Last time we talked about the main reason why we have deserts, which is high pressure cells over the subtropics. Because of those diverging air masses at the Tropic of Cancer, which is 30 degrees north latitude, and the Tropic of Capricorn, which is at 30 degrees south latitude. But there are three other reasons why we have deserts, and those include the rain shadow effect, great distances from the ocean, and cold water ocean currents along the coastline. Let's talk about those next. First, we're going to talk about the rain shadow effect. This diagram from your textbook shows you how the rain shadow effect works. And think about Oregon and Washington, for example. That's a good example of where you would see this occur in the United States. If you have a mountain range along a coastline, like we have in Oregon and Washington, being the Cascade Mountains, and if you have air masses that are blowing from offshore to onshore, you can get a rain shadow effect that can occur. So what's that mean? Well, as the winds blow onshore, they can't go through the mountain, so they have to go up. And as this moist air rises, it's going to cool. And we learned about that earlier on. When warm, moist air cools, it condenses. It changes back into liquid water vapor, making clouds and making rainfall. And so the rain falls on this side of the mountain, the side of the mountain range that's facing the ocean. And that's called the windward side of the mountain. Wind, WINDWARD. So all the rain falls on the windward side. By the time this air goes over the mountains, all the water's already gone out of it. And so then the air sinks on the other side of the mountain, which is called the leeward side. My last name, LEEWARD. And so you have sinking air. When air sinks, it heats up. It's called the adiabatic effect. And so you have hot, dry air sinking downwards on the leeward side of the mountain. Bottom line is, you have a low pressure cell on the windward side, and you have a high pressure cell form on the leeward side. So where are you going to get your mountains? In western Washington or eastern Washington? You're going to get wet weather on the windward side. Think of Seattle and Portland. It rains all the time there. But when you get to eastern Oregon and eastern Washington, we have a desert called the Mojave Desert because of this rain shadow effect. The rain shadow effect once again occurs when you have warm, moist air blowing towards coastal mountains. You will form a desert on the leeward side of those mountains. Third reason for deserts is some places are just located so far away from the ocean that you will form a desert. Let's take a look and see where that occurs. Here in Central Asia, you have the Taklamakan Desert. And the Taklamakan Desert occurs in places like Uzbekistan and in Kazakhstan. And these countries are have big deserts for the simple fact of the matter that in the Gobi Desert here in Mongolia. So Mongolia and the Taklamakan are located more than 1,000 miles, more than 2,000 miles from the ocean, and so there's not enough moisture reaching these areas, and so you can have a desert. It's another reason for a desert is some places are located far, far away from the ocean. Fourth reason to have deserts is cold water ocean currents moving along the side of a coast. Remember when we talked about upwelling before? Well, upwelling occurs where? It occurs off the west coast of North America, the west coast of South America, the northwest coast of Africa, and the west coast of Spain and Portugal, as these cold water ocean currents move towards the equator, and also off the southwest coast of Africa. Well, in places like that, you have deserts formed because of cold water ocean currents. Now, how can cold water ocean currents form a desert? Let's take a look. Okay. Let me see if I can find a picture of a desert like that. Let's take a look at the Southwest Africa. Okay, Southwest Africa. I don't know if you read about this in your history books. I'm trying to get a good picture of it for you. I forget what it's called. I think it's called the Kalahari, but desert. These areas are located close to the desert. I mean, close to the coastline. So, bottom line is, why do you get deserts form in near a coastline? Is because cold water ocean currents. Here's another. Let me get another picture here for you. You can see how dry they are. Cold water, when cold water currents move along coastline, they cool the air. Cold air can't hold as much moisture as warm air, so you're going to get very low humidity. It's going to be very dry, and you're not going to have rain. You're not going to form low pressure cells. So cold water ocean currents form deserts. I'm going to try to get you a picture right next to the ocean here. Yeah, cold water along the coastline, moving in zones of upwelling, can form deserts, as you can see here. Okay, let's go back to our book. We're coming close to the finish line. We're almost done. Oh, click on all the videos. This will show you how the rain shadow effect works. Let's talk about some of the things that you'll see when you go to a desert. Many of y'all haven't been to a desert, but I lived in Las Vegas for 3 years. I worked as a government geologist, and I take my kids out to the desert. It's such a beautiful place. It looks barren, but there are so many things to see geologically speaking, and the organisms that have adapted to living in the desert are quite interesting. Um, Coyotes won't bother you. Be careful of snakes; some of them are poisonous. But it's dry 12 months a year. And one of the things that you're going to see when you go there is desert varnish. Let me show you what desert varnish looks like. When you go to Las Vegas, don't just go to the casinos. Go out into the desert and look at some of these geological features. You also see ghost towns. There are towns that are from the 1800s that are walk into the saloon and everything is just like the old west, only there's no people there. And you'll see lots of this black film on these rocks. That's called desert varnish. And the Indians used to draw pictures on the varnish. What causes this varnish to form? Well, this varnish is manganese oxide. And when it rains, microbes, tiny little creatures, start to dissolve the rock chemically, and it leaves behind a black, thin varnish called desert varnish. So that's what desert varnish looks like. When you're in the desert, wind is more important than in other environments in terms of moving sediment. Having said that, from the previous video, you might recall water actually does move more sediment than wind in the desert, but wind is more important in the desert than in other environments. And when the wind blows, the bigger particles, the coarser particles, are going to move along the bottom of the desert. They're going to be pushed along the bottom, or they'll roll along the bottom. Your fine grained stuff, things like silt and clay, will get blown away, and they can be blown away for more than 1,000 miles away from the desert to far away places. And the medium stuff, things like sand, medium sand to fine sand, it's too heavy to get blown away a great distance, and it's too light to be pushed along the bottom, so it sort of bounces up and down as the wind blows it. So what happens to the coarser stuff? Well, the coarser stuff can't move very far because it's big. And it gets left behind. So the big stuff is too heavy to be moved very far, and it gets left behind, and it makes this desert pavement. This is called desert pavement. So this is the second feature that we're talking about in terms of deserts. You get, when you see it, almost looks like humans laid it down, but it really, the wind blew away all the finer grain material and left this stuff behind, and it's called desert pavement. The important thing about desert pavement is once you form a desert pavement, then sediment can't be blown away anymore, right? It sort of covers up the finer grain stuff so that you can start to build up a desert soil, and you can start to grow things on it. So here you can see how it happens. It's to form desert pavement. You blow away all the finer grain material, or some of it just bounces away, and then you leave behind the desert pavement. And this process is called deflation. You're taking economics with my good friend Bill Schramm. He'll say deflation is the decreasing price of costs and services over time. Right now, we're not worried about deflation, we're worried about inflation. But in geology, deflation means all of the finer grain sediment gets blown away, leaving behind a desert pavement. So now we know what desert pavement looks like. Now we know what desert varnish looks like. What happens to the sand then? The sand, um, it's too light to be blown away great distances, but it's still moved a couple hundred feet, a couple hundred feet, a couple hundred feet, and it makes sand dunes. So I mean, there must be pictures of sand dunes here. Let's see if we can find them. Okay, sand dunes, you can see here, get blown by the wind. So I don't know if you've ever seen a sand dune either on a beach or in the desert. Do you have anybody in your family who served in the military in Afghanistan or Iraq? If you do, thank them for their service. But when my son was in Afghanistan, and the sand, he would tell me the sand dune was in one place, and then a couple of months later, it had moved down like 30 or 40 feet. How does that happen? Well, the sand moves up the slope and then moves down, and it makes cross bedding. This gets preserved in the rock record. So, sand makes sand dunes. Sand dunes are made by the wind. And what happens to the finer grain stuff? Well, the silt and the clay can be blown away for hundreds or even thousands of miles away from the deserts and form a deposit which geologists call loess, Loess. This is what loess looks like. It's made of silt and clay, and it's blown away from desert areas or glacial areas too. We're not going to have enough time to get into glaciers, but from glacial or desert areas, the silt and clay can be blown away great distances to form huge piles of this loess. This loess is made of silt and clay once again, and it has almost no structure to it. But the great thing about loess is it can be weathered to make very good, rich soils. The soils of the Midwest were blown in from desert and glacial areas, and they've been weathered to make wonderful, wonderful pedalfer soils. Loess, Loess, loess. Where do we find deserts in the United States? Let's say your little brother or your little sister asked you, where do deserts form in the United States? Would you say it's in northeast, southeast, southwest, or northwest of the United States? I'm talking about the lower 48 states. It's in the southwest, and it's in a place called the Basin and Range Province. That's where you're going to go to find deserts in the United States. Now, you do have a few deserts here up in north, the Mojave Desert, due to the rain shadow effect, but most of the deserts are here in the southwest, and that means Nevada. Nevada is an interesting state. Uh, Most of the state is owned by the federal government, and there's very few people living there, except for in Reno and in Las Vegas. You also find deserts in eastern Utah and in eastern California, in what we call Death Valley. Desertification is the process by which deserts are growing. And we don't want our deserts to grow anymore because uh, desert soils are not good for growing crops. And we are very worried about deserts growing, especially here in Africa, because there's very little cropland here in northern Africa, and so we want to stop the deserts from growing. How do we stop the deserts from growing? Well, we've learned a lot of lessons in the past, and one of the first things we learned is not to cut down all the trees, because trees hold the soil in, and are going to slow down the movement, the desertification process. Irrigation, that means tapping the groundwater so you can irrigate areas. But when we're doing that, we have to make sure that we recharge the aquifers so we don't run out. And that means having a good water um, supply system so that we inject water back into the aquifer from wastewater plants, which clean up the water. We need to not plow the ground as deep, because when you plow the ground deep and then you have a drought, then the soil will get washed away. I believe we've covered everything. Um, so I don't want to give you any more pressure. I know that you've got a lot of stuff that to study for this test. You got deserts, coastlines, and then you have all of that water, surface water and groundwater. And so that's all we're going to cover, and then we'll have a test on Wednesday. In the fall, I hope that we can go back to school. I don't know if what's going to happen with this crazy situation, but study hard for that test, and I'll talk to you later. Actually, I won't talk to you later, but if I see you around campus, say hello, and I'll say hello. Okay, bye.